Law of cosines actually kind of looks like the law of sines, or excuse me, the Pythagorean theorem, except it's got a little fudge factor. So if we start out with a squared plus b squared, or a squared equals b squared plus c squared, and this will hold for any triangle, you're going to subtract 2 times b times c times the cosine of the angle opposite that side. So cosine, I'm using alpha here, cosine of alpha. Likewise here, b squared equals a squared plus c squared times 2ac. This time would be cosine of beta, opposite angle B, or opposite side B. And last but not least, and if you wanted to try and pause the video or just think ahead of me, that's great. But you should be able to get the pattern here. It's always going to be a minus 2 times this, a times b, cosine of the angle opposite C, that would be gamma. Nice. Now, this does default to the Pythagorean theorem if you have a 90-degree angle, because the cosine of 90 would be 0. So all those terms would be, they would just disappear. Why do we care about the law of cosines? Why do we have to use the law of cosines? Great question. Not everything is set up to solve for law of sines. So let's take a look at this. This is called the Purkett triangle. Archaeologists use this to help decide if a bone is male or female. It depends on the length of this side here. So let's figure that out. Or this problem here, right here. So those numbers are written down for me over here. And let's turn that into something that we can kind of relate to a little bit more. Let's just give it some A's, B's, and C's. We want to figure out the length of this side. Now, there's a problem if we try to do it directly with what we're accustomed to. So let's use A, B, and C, and alpha, beta, and gamma. Beta's got a little bit of a tail there. Mostly it does look like the B that we're used to. So let's see. We'll call that 53.6. And then we'll call this one 30.5. And then this is 86.3 degrees. So the problem in terms of using the law of sines is I don't have any side and angle pairs. I don't have any complete pairs of that. So I can't use the law of sines here. I've got to use something different. And that something different is the law of cosines. Now, if we're interested in the length of this side here, so that's going to be the side opposite this. I want to use the form of the law of cosines that involves this side. So that would be a squared equals b squared plus c squared minus 2bc cosine of 86.3 degrees. Okay, let's fill everything in. 53.6 squared plus 30.5 squared minus 2 times 53.6 times 30.5 times cosine of 86.3 degrees. I guess I was a little inconsistent here. I probably should have put cosine of alpha instead of just plugging in the angle. Obviously, this is something you want to do on your calculator. And we should be able to do this in a couple easy operations. So let's go here and I'll clear out all this old stuff. One more time on the clear out stuff. Thank you. So I want 53.6 squared. So I'll hit the squared key plus 30.5 again. Might help if I typed in a 30.5. 30.5, hit the square key, minus 2 times A, or excuse me, 2 times B, 53.6 times 30.5 cosine of 86.3. Now keep in mind, this is the square of what we want. That's A squared. So 3592.21. What do we need to do to solve for A? Well, we need to take the square root. The fastest way I can think of to do the square root on the calculator, the square root of that number, is to hit the up arrow key right here and raise it to the 1/2 power. Something to the 1/2 power is a square root. So that's going to take this answer, put it here, and then take its square root. It's about 59.94. There you go, 59.94. And I'll plug it in here. Nice. You can finish this up using the law of sines or the law of cosines. It kind of depends on you. The advantage of using the law of cosines is that the law of cosines is only going to have one solution. The law of sines can sometimes have two solutions. So you're going to have to be a little bit careful about what you get from the law of sines. You know, you want to choose the solution so that the shortest side matches up with the smallest angle, and the largest angle matches up with the longest side, and so on. So you're going to actually have to think a little bit. But there is a different way to work with these things to try and find these angles that'll give you the exact solution, and I'll show you that in the next problem. So are we okay with this much? You can find the law of sine, use law of sines or cosines to finish that up.
Yes.
Thank you. Let's look back here at another problem. So that last problem here is going to be this one right here. This is called the side problem. That's because we don't have any angles. We have just sides. So right away, it means you can't use the law of sines. Law of sines requires you know an angle and opposite side pair. We don't have that. But we can use the law of cosines. Now, what I would suggest is that when you're doing the law of cosines for something like this, that you don't just substitute things in here. It's easier if you solve for cosine of your angle first. So you'd move these terms the other side, divide by the -2 BC or whatever this term is, and that negative, well, I got rid of it by flipping some signs. But see if you can't figure out the pattern here. Here's your alpha, and you have BC and then A. Of course, A and alpha are opposite, and then this is a 2BC. Beta and B, and then the other two angles are A and C, not angles but sides. So can you figure out what this one's going to be? What squared plus what squared minus what over what?
A squared plus B squared minus C squared over 2AB.
Nice. So you've got three different versions of this depending on your triangle. And this is another little thing that I would add to my sheet. If you have it here, it's just so much more user-friendly to solve. So let's see if we can't do that for the triangle that we were given. Let me go back here and let's see here. We've got A, B, and C. Let's see. And then I'll use lowercase for the actual sides. So just kind of following along with the notation that we have here. The sides have lengths 5 for A, 7 for B, and 8 for C. So from smallest to largest, that means the angles should also be in that same order, from smallest to largest. Now, it doesn't really matter which one you pick here. So let's just use the first one, in which case I'm going to fill in this formula. Cosine of alpha equals b squared plus c squared minus a squared over 2 times bc. So that's going to be, let's see, 7 squared plus 8 squared minus 5 squared over 2 times 7 times 8. And let's just get a nice fraction for that. So in the numerator, it's going to be 49 plus 64 minus 25. This is going to be 88. And the denominator is going to be 2 times 56, which is going to be 112. And that's your cosine of alpha. Cosine of alpha equals 88 over 112. That still hasn't gotten me alpha yet, though. What am I going to do to get alpha?
Take the inverse.
Yep. Alpha is going to equal the inverse cosine of 88 over 112. So cosine inverse, make sure you're in degree mode. 88 divided by 112, 38.21. So, okay, 38.21. That should be my smallest angle. Now, if you have to solve the triangle, that is, you have to get all three of them, I would suggest you use the law of cosines to do one more. Because if you use the law of sines, then you could end up with that ambiguous case where you've got two triangles and you got to figure out, well, which one do I need? Law of cosines has exactly one solution. So let's see if we can't make that work for us. Let's solve for just side B here. So it's going to be, if I want to solve for side B, actually angle B, I guess I should say, then I want cosine of beta, or B, equals a squared plus c squared minus b squared over 2ac. A squared plus c squared minus b squared over 2ac. Plugging that in, it's going to be 5 squared plus 8 squared minus 7 squared over 2 times 5 times c is 8. So in the denominator, I just get 80. In the numerator, 25 and 64 is 89 minus 49 is, oh, it's 40, right? Let's just double check that. It seems like it works out too nice. 5 squared plus 8 squared minus 7 squared, 40. Wow. So that gives me 1/2, or cosine of beta equals 1/2. Ooh, does anyone remember what the inverse cosine of 1/2 would be? Or can you figure it out without punching it into your calculator?
60.
60. So nice even 60 degrees here. Do I have to do this mess again to find C?
No.
No, I hope you don't, right? That should just be, you know, a total of 180. So we can subtract 180 minus 60 minus 38.21, you get 81.79. And you're done. Nice. One thing to do is look back and double check. smallest angle, shortest side, largest angle, longest side, middle and middle. It lines up perfectly. It's not a complete check of your work, but boy, if something's wrong at that level, you absolutely know something is wrong.
And Professor, that applies to the law of sines also, right?
What's that?
Does that apply to the law of sines also?
Oh, absolutely. Yeah. If the sides, in terms of their proportions, don't line up, then it's wrong. You just tell you right then and there it's wrong. So it should be something that jumps out at you. If I had this side opposite this angle, so wait a minute, that's the longest side, the smallest angle, you know something's wrong. So yeah. Mhm.
Thanks.
Any other thoughts or questions on this? All right.